Welcome guys to this new stream on my channel, and as you can see in the title, finally getting to instance rendering, which is like very cool. Let me set a few things up. Yeah. Okay, so today, I said, 1 week ago or something, we get to instance rendering, and yeah, I think that that will be pretty cool because let me see if the music is not too loud. Let me see if the music is not too loud. It's too loud. Why? Why is it like that? Okay. Why? Why is it like that? Okay. Yeah, okay. Okay. Yeah. Okay. Before we start with instance rendering, which is actually not that hard, and no, I did not figure out 1 week how to make instance rendering work. Like the whole week I spent doing nothing. Like I did a lot on the project, but doing nothing on YouTube because I didn't have a PC. I just had a laptop, and because my mom had COVID and a few things came into the way, or how should I say it? Okay. First, let me start the game so that you know where we left off last time. So the thing is, we can throw those spheres, but for now we are doing it a bit weird because for every sphere we have a draw call, and that's not the ideal way to do it. So the first thing that we obviously want to do is we want the spheres to disappear when they're far away, because obviously it makes sense. So we're including vector and another thing called stack. And I shall let's do it here. Let's render the spheres after that. Okay, now we need a stack of ints which are called removed objects. So the objects removed, or let's say removed spheres. And now for every instances.size, for every instance, or for every sphere, we do a for loop, and we check if the length, like the magnitude of a vector, which is game instance, game player, get camera, get position. So the camera position minus the position of the sphere. Sphere list dot instances dot at I dot rb. How did we call it? Dot position, obviously, because it's already a rigid body. If that's more than, let's say, 200, or let's say 250, we want to disappear. The thing should disappear. We want to disappear. We want to push I to the stack and continue. So it should continue to the next iteration of the for loop. And now we say for u32i equals removed spheres.size. So we check every removed sphere, and just for every removed sphere, we erase it from the sphere list. Begin. Dot instances that begin. Plus removed spheres.top, so that we remove the spheres in the order like the last spawned sphere is being removed first, then the second last spawned, and yeah, I think you get it. And then just removed spheres.top, so that we don't process an object that we removed 2 times or more than 1 time. Yeah, that's pretty much it. Let's test it. Let's see if the objects disappear if they're far away. They do. Like, let's test like 30 to make sure if they really do, or maybe it just was clipping. I hope not. Yeah, they do disappear. Nice. Okay, that's, yeah, I think 250 was pretty okay. Yeah, okay. Nice. Now let's we need to do one thing, which is making meshes public and removing a P because it's not protected anymore. Here, I think in cube there's, yeah. Okay, that's the first thing. Now in our model list we need to do like basically all of the instant rendering stuff. Okay, so first we need a few new protected variables, which are already there. Did we cover it in the last episode? Huh. Maybe we started? I don't know. Yeah, let's write them out again, just for like, you know, like learning purpose or something like that. For you guys, I'm writing it out. Just again, positions and sizes. That's for the instance rendering stuff. So we have a position VBO, what is a buffer that holds our vertices, and positions and sizes. The positions are just the positions of the object that we want to, like of the instance that we want to process, and the sizes is just like the offset in the instances. Yeah, okay. Now we want to, like in init, we obviously need to initialize the OpenGL stuff, because for now it's just a U32. So for that, just GLGen or GL create buffers 1 and position VBO. Just for creating the position VBO and the gender, then just binding it. And what we now need is like a can we do const expression int max instances is equal to, let's say, 200. 200 instances is the max that can be rendered in one draw call. Like, no, like not in one draw call, it's not like batch rendering, but yeah, it's not rendering more than 200. It waits for the spheres to disappear and then renders the new spheres. Yeah, okay. GL bind buffers is we bind a GL array buffer. That I don't know if this is possible because IntelliSense is not working. Let's make it in here. Okay, I think it's pretty. Let's make this, and that's I32. EU32 is better. Yeah. Okay. Just binding the position VBO, and now we set the data of the buffer. For that, just GL array buffer. GL array buffer, and then it's max instances, or max instances count. Oh, just max instances times 3. Can we do size of GLM like 3? That'd be cool. Let's see if that works. Let's see these here out. Just to check, because here intelligence is working. That works. Nice. Okay, so we do max instances times size of GLM vec 3, which is just like providing the byte size to store all the data of the positions of the instances. GL dynamic draw, which is what we want to do. Yo, it's me, Mr. Maxi. What's up, bro? Glad to see you here. Yeah, nice. Glad to see you in your stream. Yeah, I'm working on instance rendering, which is a rendering technique that's pretty fast. So that's pretty cool. Okay, so null pointer for the data, because we don't want to store any data for the moment. Because it's dynamic draw, we can append data to the buffer as we want. And that's just the purpose of instance rendering, like having a vertex buffer object for which we append data during the runtime. Because if we did a geostatic draw, it would not work. Appending data during runtime. Like, I think it would work in weird situations, but dynamic draw just gives us access to a place of the buffer that is being dynamically allocated. As I know, I guess it's like that. Oh yeah. No, please stop. Okay, then just unbinding the vertex buffer again, because now let's copy that and just create it for the size VBO. So I want to create the size VBO, and yeah, that's pretty much it. It's completely the same, obviously, because like it's just the same thing. 50 subs. Wow, that's nice. 50 subs, nice. Like that's a pretty nice number, I guess. That's actually nice. Yeah, I'm actually missing Karan Hamdallah. I didn't see him in the streams like for a long time. I hope like he comes again anytime. Would be pretty cool. But next to Mr. Maxi, like very honorable guy. Really. GL binds vertex array, so for every mesh, like that's the iterator, which we set to 0, and then we define like U32, which is the iterator, and then a U32 for the size. And the size is just that we can both use the variable in the for loop and use it here, and that's pretty nice. Yeah, that's like a weird way to write a for loop, but it's possible. Yeah, okay, we want to bind the vertex array at model.meshes.va .add I, because meshes is a vector.vao, because every mesh has a VAO. So we want to bind the vertex array, and then we want to bind the buffer. Which buffer? The position buffer. Position VAO. Which is just to bind the instance data. It's 3:32 a.m. Wait. 3:32 a.m. That can't be possible. Or is it? Like, in my time it's 4:09 a.m. Yeah. I don't know. I think it like 5:09 would be possible, but not 3:32. Or am I just dumb? Yeah, whatever. Now what we want to do after binding the buffer is setting the vertex layout. And setting the vertex layout is pretty easy, obviously, but because like it's the same VAO, for that we also did that stuff, like setting the other part of the layout. We need to start at 3 because at 2 we stopped doing the layout. Like that's the layout from 0 to 2, and now at 3 we need to like at the index 3 we need to keep going with it. Where is it? Karen Paul, what's up, bro? Glad to see you here in the stream. Nice. Yeah, as you see in the title, I'm working on instance rendering, which is pretty complicated actually. So we want to do a new vertex attribute pointer. I now go to bed soon. Where are you from? I'm from Germany, as you can probably hear. Yeah. Okay, we want 3 for the size, obviously, because like it's a vec3 for the size, for the position, and the third index, because like we stopped the layout at index 2. GL4 is for normalized, and the stride is just size of load times 3 because like it's a 3D vector, and the offset is nothing. And now just enable. Oh, nice, yeah, pretty nice. Yeah, okay, now just enable the vertex layout for the VAO, which we bound. Yeah, now for the size buffer, we need to do the same thing, like so that we do a outseed. What's up, bro? Glad to see you here again. Nice. Yeah, I think you were my first viewer, like from all time. I don't know. I think that might be possible. Yeah, very cool. Yeah. Okay, we bind the size VBO just to do the layout for it. Like if it would be not bound, layout would be appended to the position VBO. Okay, like obviously 4 is the index, and that's for 2, and the stuff stays the same. Good on you. Yeah, I'm pretty good as well. Like doing a lot of progress with the game, mainly not gameplay, but a lot of like engine features are being like done pretty quickly. That's pretty cool. Okay, like okay. So for the 4th index of the layout, it's like just the same because like position and size is both a GL and vec3. Yeah. Okay, now we like unbind every buffer that we bound, just for clean purposes. Probably would not need to do that, but like for bug things I'm doing it. Now what we do is a GL vertex attribute divisor, which is just saying like at the 3rd index, like at this index, we want to divide it each instance, like each one instance, so that for one instance it's always using the 3rd index, and for the 4th index also we want to divide the vertex layout each instance. Like if we set 2 here, we would like each instance that we render has like here's 1, 2, 3. Yeah, I can't. 2, 3, and 4, and that are the attributes of the vertex layout. And like here we have one instance of stuff we want to render, like it's a cube. And for each cube that we render, it's like obviously in the that's just one vertex, and like there are several more of them. And for each cube that we render, we want to specify where it stops and starts getting the attributes from. And like for the next cube, it would be that again and again. And if you don't do that, it would not work, because it's taking all of the space for one thing, which is obviously not making any sense. So do that, and one here. And then just unbind the vertex array after we did all the stuff. Okay, that's it for the initialization of the model list. Yeah. Okay, what the fuck did I do? Okay. For the render, let's just, yeah, delete everything of that. We need a few, like one new. Before that, we need in the model render method, we need a few more parameters. The first parameter is just set model matrix. We want to specify if we need to set the model matrix, like if the rendering in itself sets the model matrix or not. That's a boolean, obviously. Boot, what's up, bro? HLW. I don't know what what that means, bro. But what's up? Glad to see you here. Yeah. And do draw call. Like that's the two parameters we need. Set model matrix is just, yeah, if it should set the model matrix, and do draw call. I think that explains. It explains itself pretty easily. Where is it's here? Set model matrix and do draw call. Can you run the program once? Yes, I can. Or can I? Okay, I'm in mid development, but I can run like the end result of today's session, but because I already coded it, which is pretty nice. So let me run that. Like here's the model I loaded and the lights, and yeah, those are all instances. And it's pretty nice because like memory, where is it? The memory is not affected anywhere by that. Like look at that. I mean, it's completely static, and like that's pretty nice. That's what we want to yeah, like obviously it's testing, like throwing AK-47s or something is not like the end result, that's testing. But yeah, that's the goal of today, just trying to reach instancing. And we could have like we can do it like we don't have any delay, just that we can hold our mouse button pressed. So like, let me try that. And like look at the memory, it's not even nearly affecting anything. Okay, now I can't. Now it don't works because like I have a limit of instances that can be shown. I can increase the limit. Where is model list? I have it as a macro. Let me see. Let me say like 10,000, just for demonstration purposes. Like, look at that. That's pretty nice. And it's not lagging or something. That's like a lot of ARs that are all physically calculated and like rendered and stuff. Yeah. That's pretty much the goal of the day. So, like, if you don't do rendering, like, what the fuck? I mean, you think, what the fuck? But it's actually, it's a nice thing to have. Because, like, imagine drawing a meadow. What is or meadow, or I don't know if what is called in English. Let me see, like that thing. I think it's a meadow. Yeah, bro, what the fuck? I don't want to do that thing. That. Imagine rendering that, and imagine rendering every like thing here of those green things, which I don't know how to call them. Each time, every frame, like it's like ordering like 100 pizzas, and instead of just saying in the pizza, yeah, I want 100 pizzas, like calling every single time, say I want one pizza, I want one pizza, I want one pizza, and that's 100 times. And obviously it's like not nearly as efficient as just calling the pizza at one time and saying I want 100 pizzas. Yeah, I think you got the point. Okay, what we wanted to do now is, yeah, that stuff. Do draw call. So, we say if, let me just refresh the stream, because it's weird. Okay, nice. We say if, set model matrix, so if you want to set it, then just set it here. And, yeah, and then in mesh, we need the parameter to do draw call, which we pass the parameter from the what we essentially do is pass the parameter from the model to the mesh. We will do draw call like that, and just commenting that out by do draw call, like yeah, like that. And I think that works now. Okay, nice. And now in model list, I guess, instead of just taking in the shader, we take in a bool called reset instances, which is just let me code it, and then like the code explains itself, I think. So if we want to reset the instances, just clear every instance vector sizes.clear, and for each rigid body that we have in our instances, we want to update the rigid body. Obviously, like the physics system is ticking, and we want to push back a to the position rb.position. So the rigid body holds our position vector, and we want to push it back to the let me see, I think the code is too small on stream. If yes, I'm very sorry. Just pushing the position vector back to the instance vector, like for the instances. And then just sizes.pushback model.size, like the scalar or size, just the scale of the model. Okay, pretty easy. If we don't want to do that, don't do it. Now we want like if we want to do that, we want to set a mat for every time you model, like the model mat for, because if we didn't do that, it would be 0 and we had a black screen. Just set that to 1.0f, and then render the model, our model, like the AR, like the AK-47, for example, with the shader that we passed in. And for the parameters, we take false for setting the model matrix, because we set it here, and false for the draw call. But because we don't want to do a draw call like for every instance, because that would not make any sense. Like, that's a thing that we did before, which is not very efficient. Okay, now we get like the how should we call it? 9mm Chris, OpenGL. Yes, OpenGL. I'm working in OpenGL, and what I'm doing, like instance rendering for a game I'm working on, and like that's pretty much for the engine. Let's just call it size is equal to the minimum of how did we call it, max instances, and we cast it to int positions dot size. So we check if yeah, that's just clamping the like seeing what's less max instances or positions dot size, which is one question that I gave up on that part. You gave up on OpenGL? If yes, yeah, I can probably understand that. Yeah. Now we check if size is not equal to 0. Like if we want to render an instance, like if size is equal to 0, it means that we have like reached the limit of instances that we can spawn, I guess, or render. Yeah, render. Yeah. If not, like if we didn't reach the limits, we want to bind our position buffer. Position DBO, and then instead of GLBuffer data, we GLBuffer subdata, because we can do that because we did a dynamic draw, not static draw. Offset is 0 in the buffer, like in the buffer data, I guess. Size, but the part I think I will give up is the button with build for compiling and creating executable. How will this work? How I can make it the engine compile the game without an ED? I get your point. So how do you do that? I think the you can't really compile it without an IDE if you started developing in Visual Studio, unless you just use copy all your code into Visual Studio Code, and yeah, using GCC or like Clang or something, which are just compilers that you can call from the like from the command line. You can just do Clang, or I have it installed, or G++. Yeah, like that's and you can do that with your C++ code in Visual Studio too. That's pretty easy. Like that's the part. Like I can show it to you. Just do that, and what do I have? Let me open something. Like I can show it to you pretty quickly, like C++, CPP Snake. That's just Snake that I coded in Visual Studio Code. Like Visual Studio Code is like just a blank editor with no like build system or something built in. So just open a new terminal, which is just like a CMD, if from Windows, and then just type cd scripts. Like I did a script for that, but you can type the command as in as well. Like that's a lot of things, but that's like doing your own build system, which is actually not that hard. Like with that, and that, and yeah, you have to do that. Like that's a quick batch file that you need to create, and then just call it. Just do build slash run, and it's building. And oh, ooh, I hate it. Okay, maybe don't build it. Maybe just run it. What? No, stop. Run. Yeah, it's pretty easy. You just need to have like a batch file that compiles with not the Visual Studio compiler, because like CPP compilers are not just Visual Studio. I hope that helped, bro. Yeah. Okay. Thanks, man. Yeah, no problem. Yeah. Okay. For the size of the buffer, just size times size of GLM vec3. And the data is like a vector, so that takes in a constant pointer, and for the like how should I say, the conversion between that, just do the reference to the first object of the vector, which is like taking a pointer to the vector, and with that giving you the data of the vector. That's like C++. Oh my god, Karim Hamdallah, what's up? Finally! Glad to see you here again. I love that. Nice. What's up, bro? Nice to see you again. Yeah, well, yeah, you too. You too. Love to see you here in the streams. Okay, to explain why I wasn't there for like a week. I explained that in the last stream too, but like, don't watch that. I can explain it now. Yeah, my mom had COVID, which is like pretty bad, and but now like it's okay again, and she doesn't have COVID anymore, but like 1 week she had it, and I wasn't able to like get onto my PC because I was in my father's living room all the time, because like I can't be like with my mother if she had COVID, and yeah, that was like the problem. I couldn't stream, but I actually did a lot of things on my laptop, which are done, and now I'm coding them like again, because like I did them already, and now like they're not like a lot of errors, because off stream I did it, but that was like in a copy of the repository, and that's the repository for the stream, and I did nothing off stream, like if you're wondering. Yeah, but that's now the case of situation. Yeah. Okay. Yeah, nice. And now I'm working on instance rendering, as I said before, the week of nothingness. Yeah. Okay. The next thing is just after we bind the size VBO, just get the buffer data. Let me open the chat. Yeah, I set the buffer data of the size VBO, which is like the same here, just taking the sizes vector with the same method, which is here. Okay, yeah, that's pretty much it. For the buffer, like reset up every render tick. Like, I'm binding the buffer again. Okay, now for the real draw call, just do for u32i equals to 0, and say, we can't say size, which is bad. Okay, let's say model count, or mesh count. Mesh count is equal to model.meshes.size, and I is less than mesh count. Like we want to do render instance for every mesh of the model. GL bind vertex array model.meshes at i.vao. So I want to implement the VAO, like every VAO of every mesh. And now the real draw call after binding the VAO, GL draw elements like normal, but now instanced. We need GL triangles for the mode. Count is just model.meshes at i.indices.size, like that's the indices count. And type is unsigned int. And 0 for the indices pointer because we bound the indices in the mesh. And size is the count. Size is like the model count, like the instant count. How many instances we want to draw with this draw call. Yeah. Okay, nice. That's it for the render method, and that's honestly it for the instance rendering implementation. But now that's not it for a lot of stuff. Okay, we need to do a few more things, which firstly is 55 subs. What the fuck? I just, sorry for the word, but I got 5 subs in like one stream. That's very nice. Thank you for all of the people that subscribed. Yeah, glad to see you like on my channel. Really appreciating that. Yeah. Okay, for now, we need a new shader. What's that? Wait. Are there 2 of the same shaders? I don't know. Let me see if which of them I loaded in object.ver then. Okay, weird. Let me just erase those. I don't know why they're there. Yeah, whatever. We need to just copy that. Copy that guy. Can't. Yeah, whatever. Let's just make a new shader. Let's call them instanced.vert. I think that's our naming convention, which is pretty weird. Why are they so weird? Yeah, whatever. I don't want to mess with this because I would need to mess with the file name that's loaded in. Okay, just go to object.vert, copy like the complete thing. Like it's not that much of a difference to the normal object shader, but yeah, we actually did change the layout a bit, as you can see here. Where is it? Here we added 2 more attributes. We obviously need to add them here as well, which is a offset for 3 and a size, like the scale for the 4th. And offset is just the offset in the VAO to get to the next instance. For that we did the attribute divisor. Yeah. Okay. Now we need a vector 3 for like how should we call it? Like object position is just equal to a vec3 of how do we do that? I think we can do just a size times a position. Yeah. Okay. And now, just instead of doing a position here, just object position plus the offsets that we got from the layout. Okay, that makes sense. Nice. That's it for the shader. Like that's not a big difference. Now for the implementation. that's like more probably the hard part. We actually don't need that anymore. Whereas we don't need that because we have like the lamp list. Oh, do we? Do we actually have it? We don't. Oh, yeah. Then let's just keep it with that because like it was like implementation I did for like the lamps and the spheres had like a list of models, but yeah, let's not worry about that because like yeah, I think let's worry about that another time because I don't want to like code it now, the lamp list, because it's like that cool. Yeah, whatever. Okay, now we need a new shader, obviously, because we did a new shader now. So the sphere shader, let's call it. And where do we create the shaders? Here. Instead of object.vert, we do instance.vert and object.frag for the fragment shader. Yeah. Do we have like a sphere list? Yeah, I think we have actually. Yeah. Okay. Just need to. Okay, we bind the sphere shader after we bind the normal shader, obviously. Sphere shader bind, and then just copy this because we need to calculate like each lighting for the sphere shader as well, because if we did not do that, like the spheres would be black and not affected by light, which is not that cool. Yeah, okay. That stays the same. Rendering the model, yeah, before that we need to bind the normal shader because like if we did not, the sphere shader would be bound, which is not that cool because it has a different layout. Setme, yeah, that stays the same. That stays the same too. And now let's where do we render like oh, we don't. Or do we? Where are here? Let me just, yeah, okay. We render the spheres, okay. Before that we need to bind the sphere shader, or technically we don't need to bind it, but let's bind it like for safety reasons. Sphere shader setmat for the view to view and the projection to projection, because the sphere shader needs to have those as well, because if it didn't have it, nothing would be shown, because like we would multiplying the position with a matrix that not exists, which obviously gives us 0. What's that? Oh, thank you for the thing. Thank you. Set model matrix. Yo. Yeah. Okay. Is equal to true, and do draw call we had. Do draw call is also equal to true. Okay, that's that. 8 more arrows. Oh. Okay, that's our this stuff. And we want to render the sphere list with the sphere shader, obviously. Yeah, okay, nice. Then the directional light stays the same too, but we want to render it with the sphere shader as well. Like rendering it is just setting all of its uniforms. Okay, for the lights, just render it with the sphere shader as well. Pretty basic stuff. Oh. Actually, we have missing code with the lamp list, but yeah, don't worry about that. Point lights, number of point lights, let's just set it for the sphere shader as well. Set that for the sphere shader as well. And set that for the sphere shader as well. Yeah. Okay. That's pretty much it. Let's run the program. I'm like, obviously it will not run because like it's software. Position. Not declared identifier. Position. Positions. Okay. Position. Okay, just one letter. Six more errors. Min not working. Why? Do I have to include something for this? Maybe I have to. Vorlage Parameter ist mehrdeutig. Maybe I think the best thing would be to just can we do const maybe we can. No. Can we do const expression? Probably not as well, because it's inside of a class. No, that's outside of the class. Like static const expression. Static. Okay, whatever. Let's just do define max instances 250. I think that would be the best idea. Max instances, where is it? Here. Yeah, that's it. Okay, let's see. Let's see. Yeah, okay. We can't bind the sphere shader because we probably did not initialize it. We didn't. Sphere shader, and we obviously need to delete it as well. Sphere shader. Think. Okay, that's exactly the problem I had. Okay, now the question is why? Why am I getting this problem? I did fix it, but it was like a long time ago. So that's not good. Next instances. Okay, let's just what we need to do is just like code the lamp list. That's a thing. Maybe it's because of that. Just a class lamp list, which extends model list, and the model that we want to have is a lamp. Like that. Do the stuff publicly. Having a that's not good. A std vector of point lights, just lights, and init. What's okay, nice. Just the model is equal to a lamp, like the stuff that we had here. A lamp, which has those parameters. Why is it weird? I don't know. Lamp. Why are there variables? Yeah, whatever. That's just why? Okay, how I just let me do it like this. And here let's go to, where's lamp? Here's lamp. No, it's not here. Where is lamp? Lamp. Okay, so ambient is this. Diffuse is that. Specular is just okay, 1. Point line positions at I. Oh. Yeah, let's just do 0 for the position for now. Okay, and then 3 0. Position, then the size is let me see the size. Wait, y is okay, that's the size. Yeah, that's nice. And now just that 1 0.07 0.3 f like that. Okay, and then just model list in it. And I hope I did that in sphere list. I did not. Model list image. Yeah, okay. Now for the render method. Void render, shader. Just clearing the positions. Clearing the sizes. And for each point light, we want to render that. Point light, in lights, positions dot pushback, light position, and sizes dot pushback model dot size. And then just the model list render method, calling that just to really render that in OpenGL with the draw call. Nice. Okay, that's it for the lamp list. Okay, we can close that. Now, in application, to implement that, we need, we don't need like, where are those? We don't need those anymore. But now we need a lamp list. Like we can add lamp list. That would be the best thing. Let's don't worry about the errors for now. Let's just erase them later. Sphere list init. Then we have those. Then we initialize the lamp list init. Can do that here. Yeah, and now for every light, but for every light in the lamp list dot lights dot pushback. So we want to push back a new point light, which we have the variables for, I guess. K1, K2, and K0, K1, and K2 for the struct initialization. And point light positions at I is also pretty easy. Like we have a vector of the positions for the lights, ambient, diffuse, and specular. Yeah, we don't need that. For the spotlight, I think it stays the same. And now for the real light rendering. We just have lamp list dot lights at I. No, not dot point light. Just dot render. Yeah, that's pretty good. And sphere shader. Just render it with the sphere shader as well, because we need to. And why do we have it like 2 times? That doesn't make any sense. Okay, that doesn't make sense. Okay, and lamp list dot render with the lamp shader. We need to dereference on that. Oh, hard session today, I guess, but whatever. Okay, let's run it. Ah, god. Okay, the lights work, but this doesn't. Ah. Oh, the shader's wrong. Implicit card from Vec 2. Oh, I did a few things wrong. Like, that's wrong. Yeah! I love everything. Yeah, I'm sorry for the things I do when code works. Like, that's like usual habit that I have. Okay, nice. Let's now okay, now let's try doing the thing, but with, you guessed it, a rifle. And let's make the size like 0.25. Let's see. Okay, that's definitely too big. Let's say 0.02. Let's see. Oh my god. And they are lit, like they're influenced by the light, by the directional light, which is actually very cool. And obviously, wow, that's cool. Okay, that's now stress tested by setting the limit to that. And what do we want to do? We want to have a, yeah, we want to hold the mouse button. Let's stress test it. That would be cool. Okay, that's, you have to, yeah, have a look on that bar. Oh yeah, please stop NVIDIA. Please. Thank you. Oh my god. Yeah, obviously it like, that's so sweet, and like in 144 FPS, like a bit, it's a bit like, it went up by 10 megabytes, but like, don't worry about that. I mean, 10 megabytes for one rifle with the normal method, I think it would be 40 megabytes, because you, for every rifle we need to load the rifle model, and yeah, that would be like not 144 FPS. And now it doesn't even go up anymore. Oh, that's so cool. It doesn't even go up. Wow. Wow. yeah, I think that's the goal for today's episode. Like, we have instance rendering and it works perfectly fluidly, which is pretty cool. I think we could do... like the example with the woman that we had last time with not instance rendering. Like, I have the codes where it's not instance rendered, and then with instance rendering, like to have like, you know. Okay, it's player and no textures. It's false. And let's do it like that. And then we let me see, just okay, let's say if, where is it? We have the rigid body. Let's say it's not that, it's GLM vec 3 0 0 0 0 0 0, but it's like we need a variable like that's definitely testing. Just player model count is equal to 0. 0f and it's a float. And we take in player model count here. And then we do player model count plus plus. Can it start? Obviously it's not throwing a sphere anymore, a sphere, but yeah, whatever. Where is it? It's not there, I don't see it. Why is that? Ah, obviously, because we don't push back the rigid body. Where do we need to push back it? I think to the instances, if I'm not completely dumb. Like that. Yeah, obviously. Okay. We don't need that anymore. And I think let's do on the Y level like 4. Yeah, 4. Why? One error, RB. Oh. We don't need that. Let's see. Oh. Yeah, that's very cool. But the texture is buggy. I think I know why that is. But yeah, let's don't worry about that for now. Like, look at how many of these I can spawn and it's not even a bit laggy. Yeah, that's very cool. Okay, let's do like a thing. Count X, count Z, and let's say count X and player model count Z, player model count X plus plus, and let's say if player model count X modulo, let's say 20 is equal to 0. Yeah, those need to be ints, like if you want. Then what we want to do is player model count Z plus plus, and obviously, yeah, stop. That doesn't make any sense. And then player model count X is equal to 0. Yo. Oh my god. Let's. Yeah, like, that's cool. I'd say. Okay, let's make one more thing. That's okay. Let's not say 20. Let's say 40. And let's make a y. X, y, because I want my PT to suffer. Okay. And then we say if player model count z modulo 40 is equal to 0, then we just do player model count y plus plus and player model count. Let me see that player model count z is equal to 0. Let me see. Maybe that won't work, but maybe it will. I'm not too concerned if that would work. Okay, let's not say 40, let's say like for just now, let's say 4, because I want to see if it works. No, it doesn't. I think it's because yeah, let's just remove that. Because like that's, I'm not into thinking a lot right now, because I did a lot in the stream. Yeah, I'm just holding down my mouse button, my left mouse button. Okay, we also have a flashlight. Yo, it's actually kind of creepy. Let's make it full screen. That's actually cool. And it's not even nearly laggy. Yeah, I think that's it for the stream, because like we did a lot and I love it, obviously. Yeah. Next time I think we will do like the problem with the textures or something. But yeah. Okay, I think that's it for the stream. I hope you enjoyed it. If yes, then consider dropping a like, or look at that. It's like that static, the RAM usage. Consider dropping a like or following, if that would be very cool. Yeah. Okay, so hope to see you in the next stream, and I think me and that woman